Today we are looking at basis vectors in spherical polar coordinates. We'll be looking at them around here. And just a reminder of spherical polar coordinates, or the version we're using, because there are many different conventions. You've got a point x, y, z in Cartesian coordinates here. And you're measuring the distance out from the origin is r, and the polar angle is theta, we also call the colatitude, and the longitude is phi. So we're looking at a point here, which is at x equals 30, y equals 1, z equals 0. And we're going to be staying in the xy plane with z equals 0 for the time being. And in terms of polar coordinates, that's at 30 out, sort of 90 degrees polar angle, which puts it in the xy plane, and 2 degrees longitude, which is phi. The interesting thing about these basis vectors is that in Cartesian coordinates, the basis vectors always point in the same direction. But in curvilinear coordinates, such as spherical polar, they don't. And then the direction that the basis vectors point in depends on the position you're at. So now we're going to vary this position. We're going to move around the equator. And here you'll see what's happening. Okay, the r, the radial basis vector, is always pointing straight out from the origin. The polar angle, polar vector, is always pointing downwards, straight downwards in this case, because it is showing where you move if you sort of increase the polar angle. And likewise, the phi, which is the longitude, as you increase it, it sort of moves you around the equator, and that is like going forward all the time. And now we're going to have a look, see what happens if we go over the equator. So we'll stop that here, and we'll make a little adjustment. Oh dear, to the what's happening, and hopefully that will get back in roughly the right position. And now the plan is that we're going to go woo over the top. So if we and we'll actually go back and start right on the y-axis. There we are. Oops, I think I made a mistake here. Oh, so I have made a mistake. Right, oh, there we go. Right, that's better. I fell to pieces of it. There we are, we're right on the y-axis. So our point is now going to move up. Now you may wonder what will happen. Try and work it out for yourself. Anyway, here we go. Oh, it's moving down as it happens. Okay, we're now going around the back of the sphere. Okay, now we're coming up to the top. Let's just stop it. We've still got the radius, the r basis vectors pointing out from the origin. And now we got, as you increase r, you sort of go outwards, that's why. And then you got the theta, which was the polar angle. That is pointing sort of downwards, but it's sort of like parallel to the lines of longitude, and parallel to the lines of longitude. And phi is pointing to take you round the globe at a certain line of latitude. Okay, so we just carry on a bit more. Whoops, it's a bit. It's a bit jerky sometimes, apologise for that. We're now going back the other way around. Now you see something quite odd happen as we went over the South Pole. The phi basis vector completely changed direction. If you think about that, that's entirely correct. But now we're going, sorry about this, there we go. Okay, and the theta for the vector is still always like pointing sort of downwards, and whoops, it goes over and we go over the top. It's like still pointing downwards, so it's got to do that flip. Both those vectors have got to do that flip as you go over the north or south pole. You can also see that the length of the vector, particularly the phi vector, is sort of changing quite dramatically. They are sort of, they're not shown to scale here, but otherwise they would be much too small. Okay, well, I'll let it come round one more time. And we also might have wanted to see the contravariant, the covariant basis vectors, or the one forms. And in fact, I can tell you they are pointing in exactly the same direction. And the radial one form basis vector is exactly the same as the basis vector. The other two are scaled up by a factor which depends on the position. Okay, thanks very much. Bye for now.